I'm going to introduce you to Ladybug, which is a plugin for Grasshopper. And it uses global climate data in geometry, in our case from Rhino, to perform complex climate and energy studies. Here you can start to see sort of the variety of capabilities of Ladybug. The website's actually a great resource. It has tutorials and example files and scripts for you to download and explore. This one in particular, I pulled from for a good portion of the script I'm going to show you today. It's by Chris Mackey. I encourage everyone to check out the site if you're interested. Now I'm going to jump over to Rhino, and these particular are some of the diagrams that we're going to do today. This set is a thermal comfort study, which is more about the quality of and human experience of the space. Well, this set is a radiance study, which is really sort of a measurement of energy. While it does affect temperature, it's more about building envelope performance. So this is the base model that we're going to start with. And in it, it has our design building, the topography, and any relevant context buildings. And the design building is a simplified massing. But that's where we're going to start.
That's SCAD, right?
Yeah, so it's a SCAD in Atlanta. And we're an early version of SCAD. So I'm going to launch Grasshopper. And just for brevity, I'm going to assume everyone has sort of a working knowledge of Grasshopper and Rhino. Set up. Script. And so I will preface this by saying I only use this for visualization purposes. You know, I'm not an energy modeler. I'm not really an expert in Ladybug, but this script is good for quick studies and quick iterations. So it's divided into a few different chunks. The white here is really just launching it and importing data, which you have to do anytime you use it. The purple is the thermal comfort script. The green is the radiant study, and the blue are a couple other diagrams that you can just do with the weather data. You don't necessarily need external geometry. And this script will be made available. So what I'm going to do is I'm going to start with just sort of a quick plug and play, how to get you in here and get your graphics out as fast as possible. So anytime you use Ladybug, you can start with this, which just sets up a default folder. This panel just lets me know that it's working. And then you're going to import the weather data. So you just click this button, and it launches a website where you find your site. This, like we said, is in Atlanta. You find sort of the closest station possible. You're gonna copy the clipboard, and jump back in Grasshopper, and in this panel, you just paste it, the URL. It'll actually pull that data from the website without you having to download it, which is pretty cool. And in there, we have sort of hourly, annual data for wind speed, temperatures, and then what this is going to do is it determines an analysis period. And, by default, it's just a typical week, but you can really pick anything you would like. Just stick with that for now. So after that, we're going to move on to the thermal study. And so for that, we import the geometry from Rhino next. And this is a study on the topography, sort of the thermal comfort on the ground. First, I'm going to assign all the buildings as the buildings here. Topography. And then this slider is really a resolution. So it creates this mesh and divides it into a grid of test points. The higher the number, the larger the grid size, which is the lower the quality, but faster processing time. And at least for this model, this processing takes quite a bit, so I'm not actually going to perform it. Even at low res, it takes 20 plus minutes. previews. After you import your data, or your geometry, then you use that with the weather data to sort of create an adjusted radiant temperature in relation to the buildings that you're designing, the buildings on your site. And what you would do next is you would click this button, and it would then create that mesh. But this is the one that takes a while, so go ahead and not do that. And what it's doing is it's taking this adjusted radiant temperature, and it's then taking your average temperature, your average humidity, and your wind speed for the selected analysis period. All four of those categories, and then it's going to calculate your thermal comfort. And then what this is doing is it's visualizing it on a mesh. So as soon as you click this, you should start processing, and a mesh will pop up, and then I can kind of show you what that would look like. And for reference, this was the grid over here was set at 2, and it took over an hour, but I was pretty happy with the quality. And then this legend all here is just sort of controls how this is displayed. And since I didn't run it, I'm not going to show you right now, but I'll show you in the next one. And for this type of diagramming, I also like to include a sun path. And all you need to do to generate that is plug in the location from your climate data. Well, that's not the right one. And then this controls daily or hourly, because the data set is hourly. There you go. Now you can customize that more with these options, but that'll get you, that to start with. You can bake that out and do whatever you want with it. And render it out in your sort of your preferred method. I'll leave that connected for now. And then since the thermal comfort, while it does take into account wind speed, it's not really a wind simulation. That's sort of a much more involved process. So I do like to include a wind rose. And all you need to do is input your wind information. This guy. Wind speed. Plug this here, I'll convert it for us. It is by default, everything's a metric, so you have to use conversions. And this was correction, I hope. And then your analysis period. And click this button to run it. And you can see it pop up right under there. By default, everything is generated at the origin. You can change that if you like, but for now we're going to leave it there. And again, this legend sort of controls how everything is displayed by changing this number to 0, which is your default. And everything is explained sort of if you hover over these. Ladybug does a really good job of explaining all of that. So I will not get too much into that. So that's what I like to do for the thermal comfort. I'm going to move on to the radiance. That's set back. And the radiance is actually even faster. First, you have to sort of basically generate radiance values for the entire sky. And you're just going to plug in your EP, your EPW. And your chosen analysis period. Again, click the button to run it. And this one actually pops up. This This one will take a second, take about 30 seconds. Or maybe a little faster. So that feeds into this gradient analysis tool. And for this one, I think, so if you remember over here, you can either perform this on the building or on the ground. I'm going to go ahead and perform on the building, I think, right now. So our geometry then would be the building. Set that as your design building. Sorry, and we're going to set all of our context. Go. And you run it. And so I thought I assigned it wrong. For these values, let me try that. So there, it's already calculating it, but it's not taking these context buildings into account. You add those, you may see it adjust. So this has a similar grid size as the other one. It doesn't seem to be as finicky, but you can see it's set 25 over here. It's probably set at 5 at a higher quality. And for this one, I'm also going to do a radiant rose, which is similar to a wind rose, but this one actually can take the geometry into account of the existing building if you want. So this takes the sky mix you generated in the first step. And if you run it, it'll go ahead and give you these radiant roses, but they're just sort of generic. And then if you add in your context buildings, hopefully you can see them adjust. And they adjust a little bit. So those can be site specific as well. Again, you bake those out, and you can either render directly from Rhino, you can make 2D, whatever your preferred method is. So that is the quickest way to get in there, and you just for your data, set your geometries, and click the appropriate boxes. If there is sort of interest in time, we can get into the components individually and look at some of the customization you can do.